Good day, everyone. I am Joan Cristin Alipoyo from Davao del Norte State College, Panabo City, Davao del Norte, Philippines. I will present our study entitled Age and Reproductive Maturity Using Otoliths of Yellowstriped Goatfish Upeneus vittatus. With the proponent, yours truly, Joan Cristin Alipoyo and Rosalyn P. Tejada. For the introduction, finfish of class Otoliths have three pairs of otoliths. The sagittal otoliths, or the ear bones, are the largest solid calcareous crystals located in the head region under the brain of the fish. Otoliths varied in shapes and sizes among the species of fish. They are commonly used to determine the taxon, age, and size of the fishes, and proven as an appropriate tool to identify fish species. Otoliths hold a permanent record of the life history of each fish, such as their daily age, size, growth, and ontology. Goatfish is a commercially important demersal fish group throughout their distribution around the world. It constitutes 15 genera, of where the genus Upeneus is the most important one. So this picture is the study organism, the yellow-striped goatfish Upeneus vittatus. This is a marine, brackish, coral reef associated fish and a commercially important demersal fish mostly found in sandy or muddy sand bottoms. And this species is commonly observed sold in Panabo City local market. Given the little information on life history traits of Eupheneus vittatus in the Philippines, specifically in Mindanao, this study provides an initial report on the age growth parameters of Eupheneus vittatus by analyzing the sagittal otoliths of the fish sampled from the local market of Panabo City. Further, incorporating age group data to morphometrics and reproductive maturity information is necessary to understand the population dynamics of Eupheneus vittatus in the same area of interest. Hence, this study provides information on the age structure and reproductive maturity of Eupheneus vittatus collected in the local market of Panabo City. The results provides a baseline reference for trophic studies for the identification of prey and estimation of its size. For the objectives of this study aims to establish the relationship between morphometric measurements to the age and gonadal maturity of the yellow-striped goatfish Upeneus vittatus. Specifically, it aims to determine the morphometric measurements of Upeneus vittatus, determine the age of Upeneus vittatus through its sagittal otolith increments, correlate the standard length of Upeneus vittatus to its otolith size and weight, correlate the gonadal maturity to the age of Upeneus vittatus, and correlate the morphometric measurements to the age of Upeneus vittatus. Materials and methods. The collection of Upeneus vittatus was conducted at the local fish market of Panabo City, Davao del Norte. The laboratory analysis was conducted at Davao del Norte State College. The sampling was conducted from March to September 2020, and a total of 104 individuals of Upeneus vittatus of varied sizes were collected. Collected samples were then brought to the laboratory for the measurement of total length, fork length, and standard length, and for total body weight. After which, the fish was dissected to remove the gonads and otoliths, which was processed in the laboratory for sexing, gonadal maturity staging, and sagittal otolith analysis. For the data analysis, morphometric measurements of Upeneus vittatus were determined by getting the lowest measurements, highest measurements, and mean measurements of the total length, fork length, standard length, and weight, separating male and female and the undetermined sex. Otolith morphometrics were also determined by getting the lowest measurements, highest measurements, and the mean measurements of the length and width of the left and right otoliths. Estimated age of Upeneus vittatus was determined by counting the annual rings in the otoliths of each fish sample. Pearson coefficient of correlation analysis was carried out to show the relationships between the standard length of fish and weight of otoliths and the standard length of fish and the length of the otoliths of Upeneus vittatus. The relationship between the fish standard length and otolith morphometrics were interpreted in the scatter plot graph via simple linear regression. The relationships between the fish size and otolith morphometrics were also interpreted in the scatter plot graph via simple linear regression. Pearson coefficient of correlation analysis was also computed to determine the relationships between the age and the gonadal maturity of male and female Upeneus vittatus. The relationships between the age and gonadal maturity of male and female Upeneus vittatus were then interpreted in the scatter plot graph via simple linear regression. Moreover, the relationship between the fish morphometrics, like the standard length, otolith width, and the otolith weight, and the age was computed using multiple regression tests. Results and discussion. The sexes of Upeneus vittatus samples were identified. Out of 104 specimens sampled, there were 30 male, 42 female, and 32 individuals with undetermined sex. Table 1 shows the body morphometrics of Upeneus vittatus samples collected in Panabo City local market. The body morphometric measurements of Upeneus vittatus had a maximum total length of 27.60 centimeters in male, 28.20 centimeters in female, which is comparable to the maximum total length established by fish base of 28 centimeters, with a common total length of 20 centimeters. Table 2 shows the otolith morphometrics of Upeneus vittatus. The sagittal otolith morphometric measurements of Upeneus vittatus show that the length, width, and weight of the left otoliths were very similar to the right otoliths. This suggests that they are mirror image from each other. Otolith morphology can also be used as parameter in identifying the species of fish because otolith structure differs from one species to another. Morphological studies of otoliths are very important. That paleontologists, archaeologists, and oceanographers have recorded otoliths in the sediments and have determined species of fishes from otoliths. Figure 2 shows the estimated age frequency distribution of male, female, and undetermined sex of Upeneus vittatus. The estimated ages range from 1 year old to 9 years old, with total lengths range from 9.9 centimeters to 28.2 centimeters. The maximum ages of male and female were 8 years old and 9 years old respectively. The results suggested that there were 9 age groups that can be detected on the otoliths of Upeneus vittatus. Figure 3 shows the gonadal stages and age distribution of male and female Upeneus vittatus. Among the 100 samples of Upeneus vittatus that successfully extracted otoliths for age determination and considering stages 2 to 5 as mature, most of the specimens with ages 4 to 9 years old were mature. Specimens with ages 1 to 3 years old were immature. The male and female Upeneus vittatus begin to mature at the ages of 5 years old and 4 years old respectively. This figure shows an otolith microstructure of a 7-year-old Upeneus vittatus showing the method of counting its age based on the alternating opaque and hyaline zones observed along the sulcal groove. Figure 5 shows the scatter plot graph showing the relationship between the standard length and otolith length of Upeneus vittatus. And the figure 6 shows the scatter plot graph showing the relationship between the standard length and otolith weight of Upeneus vittatus. There was a strong relationship between the standard length of Upeneus vittatus and its otolith length, with R is equal to 0.96 and otolith weight with R is equal to 0.90. The results imply that the otolith length and weight can be better predicted given the standard length of Upeneus vittatus. This also implies that otolith length and weight are good indicators to fish size. This can be also best predictors to the length of Upeneus vittatus whenever only the otolith morphometrics are the available data. Simple linear regression test results show that there were significant relationships between the standard length and otolith length and between the standard length and the otolith weight of Upeneus vittatus. Given the achieved growth relationship values, otolith length and otolith weight can be predicted given the standard length of Upeneus vittatus. Figure 7 shows the scatter plot graph showing the relationship between the age and the gonadal maturity of male Upeneus vittatus, and Figure 8 shows the scatter plot graph showing the relationship between the age and the gonadal maturity of female Upeneus vittatus. Pearson coefficient of correlation result between the age and the gonadal maturity of male Upeneus vittatus showed slight positive relationship, and moderate positive relationship was shown between the age and the gonadal maturity of female Upeneus vittatus. Linear regression results showed significant relationships between the age and male gonadal maturity and between the age and female gonadal maturity of Upeneus vittatus. The results suggested that the age of male and female Upeneus vittatus is a better parameter to predict its gonadal maturity. Table 3 shows the multiple regression result with corresponding p-values between the age of Upeneus vittatus and its standard length, otolith width, and otolith weight. Multiple regression test results show that there was a significant relationship between the age and among the standard length and otolith morphometrics of Upeneus vittatus. Further individual test results show that only the standard length positively predict the age of Upeneus vittatus, while there was no enough evidence that the otolith morphometrics can contribute to the prediction of the age of Upeneus vittatus. The results suggest that as body length of Upeneus vittatus increases, there was a corresponding increase to its age. Conclusion: the results of this study imply that Upeneus vittatus was divided into 9 age groups, with estimated ages ranging from 1 year to 9 years old, with ages 4 to 9 years old were mature, and ages 1 to 3 years old were immature. The standard length and otolith weight of Upeneus vittatus have significant positive associations, which suggest that otolith length and weight are reliable indicators of fish size. Age and gonadal maturity of female Upeneus vittatus showed a large significant relationship, which suggests that female Upeneus vittatus gonadal maturity can be predicted based on its age. And the standard length of Upeneus vittatus positively predicted to its age. For the recommendation, it is recommended that long-term study of fish catch data of Upeneus vittatus may be conducted to compare the seasonal variation of fish sizes and reproductive maturity in relation to its age. That ends my presentation. Thank you very much for listening and good day, everyone.